111. So we were talking about this remap theta from WR to OCK, and then extend it from the fraction ideal from a fractional field of WR, so WR invert P, again to CK, it's a fraction field of CK, and then we know that it is still having a principal ideal as its kernel. So remark, firstly, so recall we have theta q from WR invert P to CK, and this is again surjective, and we denote its kernel theta q, which is again generated by C as WR1 over P submodule. Secondly, let me remark, could think of this as a sub exercise. This is not difficult. So for any positive integer, if you take the intersection of kernel theta q with WR, then this is kernel theta, and this is even true taking any power by induction. Also, we have this kernel theta q topology is separated, so the intersection is the same as before, theta. Now let's introduce the period ring drum definition. The drum ring plus is defined as Bdrum equals inverse limit of the R over P and the kernel power. So the kernel ksi-adic completion, right? Because this kernel theta is principal ideal generated by, for example, Xi. This is also ksi-adic completion. Remark that the transition maps, which is quotient, is compatible with the GK action, which means GK equivariant. And this is the completion ksi-adic topology. So now continue remark for this 3.1. So this is ksi-adically separated because the intersection of all those ksi power is 0, as we know. I mean, this is ksi-adically separated because we take the ksi-adic completion. So this being isomorphism, both telling you that it is separated and complete, right? This is ksi-adically separated. This map being injective is then the intersection of the ksi power inside B-DRAM plus is 0. And notice we have already proved that the intersection of Cn WR 1 over P is 0. For example, you could use the second remark. And then what can we say? There is an injection. From W of R injects into over P, further injects into DRAM plus. And subranes of it. So this is obvious for this one. Just look at the kernel of the canonical map using the universal property, right? Using the universal property of inverse limit, there is natural map from WR 1 over P to this B-DRAM plus. And then what is the kernel of that? Then you look at is the intersection of all those ksi power inside WR 1 over P, which is 0, so it's injective. So this B-DRAM plus the mates, a JK action that is compatible with the action on its subrings. The inverse limit DRAM plus maps GQ equivalently onto each quotient. Frac of W R quotient by power of kernel theta. naturally map just a quotient. And in particular, we have this B surjective to W or 1 over P quotient by kernel theta, and so this is isomorphic to as we know CP by either last exercise or what we have recalled at the beginning. So let's call this theta, because in a sense this is that theta map extend the source to its completion, right? Or better to call it CK, be compatible with the notation before. .3 we have, if we take the intersection of kernel theta theorem plus with W of R, in some sense take the integral parts, this gives you back kernel theta. If you want, you could think of this as our exercise. It's very easy, actually, quite direct. M over kernel theta theorem plus intersection with frac of WR is similarly gives you back kernel theta Q. And this restricts to this theta Q on this subring. Because it is the completion of this theta ksi-adically, right? And if you restrict it back to this, then this is exactly so the kernel is theta Q, because that is the extended map of actually the theta Q. So theta theorem plus is the extended map of theta Q by extending the source to the p-adic completion. So if you restrict it back, then this is theta Q itself. Exercise. So the main exercise for today is as follows. Proposition. So prove that the ring theorem plus we just introduced is complete discrete valuation ring. So this is a discrete valuation ring with its residue field. As you could imagine, CK. And what is the maximum ideal? So theta theorem plus, and what the nature of this idea is its principle. I'm gonna say it's what is it principle? Yeah, because it is a discrete valuation ring. So what is uniformiser? Any generator of actually of kernel theta Q in this level of just WR invert P is already a uniformiser. of it. Okay, so moreover, the natural map from bit-around plus to any quotient. It's identified with the quotient. It's identified with the projection to the quotient. Right. Identify the projection with maximum ideal for any value. Okay, let's say the proof. The kernel theta q is a non-zero principal maximal ideal of fractional ideal WR. Right. With, because quotient of it is maximal, because quotient with it is ck, a field. And then basically the question is to knowing that on each piece of this inverse limit, which is understood quite well, c to the power n, on each piece we kind of understand the structure, and the question is on the whole, is it discrete valuation ring or not, right? So on each piece, what do we know? So let's say for j bigger or equal than 1, the only ideal of WR word P quotient kernel to q to the power j what are the ideals? Kernel theta q to the power I, quotient by kernel theta q to the power j, with I bigger or equal than 0 and less equal than j. So this ideal is bigger. The smaller the power, the bigger the ideal. So those are the ideals. So this is a Lagrangian ring. And so this is the structure on each piece. So each piece is a Lagrangian ring. And the question is, as the inverse limit of a Lagrangian ring, what can you say? This is basically an algebra question. And so, particularly, we know what are the maximum ideals on each piece. Right? Maximum ideal on each piece is just c quotient by c, and this is the maximum ideal on each piece of it. And so we know this is a local ring. We know what are the units. So those are correspond exactly to the non-units, right? And so the question now is, what are the non-units of the inverse limit? In particular, the elements B1 plus this inverse limit is a unit element if and only if it has non-zero image under quotient by the maximal ideal maximal ideal of theta drum plus. Because we already know what are the non-units on each slice or on each level, right? And then to get a unit on the inverse limit, you have to get non-units. To get a unit on each level, you have to get a unit on each piece, on each slice, so that the units are those not fall into ksi, which means outside maximum ideal, right? And so finally, the units of B1 plus is under the map theta drum plus which means quotient by ksi should be non-zero. Because that non-zero elements here correspond exactly to those on each slice, which is not inside ksi quotient ksi, and it corresponds to the units on each slice. It corresponds to the units on the inverse limit. In other words, the maximal ideal kernel theta drum plus consists of exactly those non-units, and hence the maximal ideal, the only maximal ideal. Then this implies this is local, right? With its maximal ideal kernel of theta drum plus with residue field ck. Now let's find uniformiser of it. Now let's consider any non-unit. Let's say B pick from B1 plus. And so its image in each WR 1 over P quotient by kernel theta Q to some power J has the form B equals, so it's a non-unit, which means B bar fall into ksi, the maximum ideal of each piece ksi equals cj. This is local origin reduce the unique maximum ideal on each projection. Right, so this is principal ideal, so B equals C times some, let's call it Bj. Right. Or if you want C bar Bj bar. And you could do this. What I want to say that we could lift it to B equals C times some Bj, while this Bj, what I mean is still in plus, is unique up to modulo ksi to the power j minus 1 y. Because, so suppose you have ksi bj equals ksi bj prime, and then this implies that, because this is principal ideal domain, so ksi bar bj bar equals right in ksi quotient j. And this is principal. Tells you ksi bar bj bar minus bj prime bar 4 into ksi-j. Right. And so bj congruent to bj prime modulo ksi to the power j minus 1. So this is not unique, but it's unique modulo this, and so you just have you just got a sequence element bj, and this gives you, it's compatible with the transition maps as a remap, gives you element. Let's copy prime in the inverse limit. The inverse limit of here. Right. And this is orbital plus. More precisely, this is in the yeah, actually that's what we can say. Wait. Yeah, exactly. Okay, so this implies B equals actually C times this B prime, and so by our construction this is unique, and so the maximal ideal of B drum plus has the principal generator ksi. So ksi is not 0 divisor in B drum plus. each j bigger or equal than 1, those Cj are those sent to 0 under the projection to quotient by the kernel theta q to the power j. In particular, this implies this is ksi-adically separated. So it is discrete valuation ring with uniformiser C. Let me put this as sub exercise. Think about that. So this is the inverse limit of quotient by c power, and wow, should be obvious. So firstly, on each slice this is true, and how about passing to the inverse limit? Right, that's it. Okay, so by construction, bit around plus is the inverse limit with Artinian quotients. Hence, it is a complete discrete valuation ring.